Yeah, hi everyone. We'll be starting in a few minutes, like just the speaker is about to come. We'll be starting in just a while.
Hello all, am I audible?
Yes, ma'am, you are. So, Bashar here is our host. So, Bashar, you may begin.
Yeah. Just good afternoon, everyone. This is welcome to today's event, which is a workshop on the computer vision. I, Bashar Khabe, will be your host for this afternoon. Today, we are gathered here to learn about the computer vision, and here we're going to make it a memorable one. Before we could proceed further, I would like to take a moment to acknowledge our guest speaker for today, Miss Sarah Gowde, who have made this event possible. She's currently been working with Microsoft as a software engineer, and as we all know, Microsoft is a company we all dream of working for as a software engineer. Hello, ma'am.
Hello, yeah, sorry, I was talking on mute. um, so, yeah, thanks for the great introduction. And I hope you guys take away something from what I present and it wouldn't be boring from my end. So I'll try to make it more interactive. And I think it could be interactive only if you guys like join me in answering questions or something like that.
Absolutely, absolutely.
Yeah. So should I start presenting?
Yes, ma'am.
Yeah, give me a minute. And I really apologize for the delay that happened today.
It's
Like,
it's it's okay, ma'am.
thank you. I'll start presenting. Okay. I hope it's visible.
Yeah, it's perfect, ma'am.
Okay, cool. So let's begin. Um, yeah. So as you all know, like through the introduction, my name is Sarah, and I was a student from SPIT, which is also in Mumbai. So yeah, and like currently I'm working as an ST in the devices team, which is basically Microsoft owned Surface devices. Um, so yeah, like what are my what roles have I played prior to being an SD at Microsoft? I've been a technical intern like almost since my second year of the college. Then as I moved forward in my like journey in college, I started mentoring the juniors, and then I got into research with few of my professors in college. And then I was also a part of CSI, and I used to head the technical committee, like the technical part of CSI. So yeah, those are my roles and responsibilities. I think this slide is a bit older. I'm really sorry I couldn't update it because I had some critical issues last week. So yeah, but like I've added it last minute, so like I'll add up to what my current roles are. Like after I completed my first year, I mean after I completed my first year at Microsoft. So I mostly used to go on talks and take talks like I'm taking today about how to get into like how to be a software developer, or how to like improve your skills, or what exactly it takes to be a good engineer. So yeah, that's all about like my roles and responsibilities. Then yeah, I interned at different companies and startups. So I was an intern at Microsoft itself. Then I used to intern at Skinsy, which is one of the startups by a professor at our college, and the other one is OIT. That was another startup. So we kind of were thinking from scratch on how to create a platform for students so that they can leverage all the great material that is out there. So yeah, that's all about the internships that I did. Then skills, I've just mentioned a few, like which are necessary or which I think are my strengths. So first one is technical skills. I think all of us agree that being into software engineering or computer engineering, it's like it's really important to have technical skills. I'm not saying just like we should know how to code, but it's about how to solve a problem or how to think of a solution in an analytical way. Then there is another important skill that I feel is leadership and management. So basically, leadership and management skills are really important when you work together in a team, or when you're supposed to like gather like gather a lot of information to enhance your knowledge, and then use that information to help others and lead the team as a whole. So that is those are another skills I feel are really important, and I think I'm still learning. But yeah, I'm pretty sure that everybody in their life would continue learning the skills forever, like technical skills also, and the other two skills that I've mentioned that as well. Then these are my hobbies. So I like music. I was into classical singing for like my entire school life, and then yeah, then exploring stuff, be it technical or non-technical. I really like exploring things. If I have questions about anything, or if I just wonder, when I sit idle, I wonder something, I just start exploring it. So that is one thing. And gardening, I got a hobby of gardening when during the COVID time. So yeah, like those are some hobbies that I have. And then these are some offers that I got during my college period, and there are a couple of more that I've not added because as I said, it's not an updated slide. So yeah, that's pretty much about me. um, okay, one question: are you seeing my entire slide, or is there any interruption in between? Like, I just wanted to confirm there's nothing interrupting the
No,
presentation.
it's good, ma'am. We can see it as a whole.
Cool. Okay, thank you. So yeah, I think I messed up my animation, but let's go. So the interview or the internship interview process. So basically, let's go into like computer vision after we talk about how I landed up an internship at Microsoft, and then uh, how I converted that into a PPO. So basically, we all know that we have an online coding round. Then there's a telephonic interview round. Then there's an on-site interview round. Basically, there are two on-site interview round. It depends on how you perform in the first one. You have the second one. Then there could be two things. You could not do well, or you could do well. So even if you do well, you have to continue preparing or continue learning. It's not like you have to learn to get another good offer. It's about learning to improve yourself. And then even if you don't be disappointed. It's the part of the process. Everybody fails some or the other time in some of or the other interviews. So like uh, buckle up and prepare yourself for the next rounds. Then in my case, it was a good ending, and I got a internship at Microsoft. So basically, I would say that your online coding test would be your most important phase, because you will have to like complete a piece of code or like three sums in a given period of time, and that is like really difficult. So like focus on more of preparations when like focus more on solving problems rather than just understanding what the problem would be. Like, we have a tendency that we'll see a problem, then we'll go to the Google, we'll Google it, and then we'll be like, yeah, this was easy, I could do it. But that is not how the process should be. The process should be like, you see a problem, you try to solve it on your own. I'm not saying you should not look at the Google solution or any solution that you have, but the thing is, you need to try to understand what the solution is. And that is how I'm going to keep this presentation as well, like the computer CV thing as well. I want you guys to understand each and every line of the code that you're writing. and that is why maybe I wouldn't really get into a like a hour long demo or something. I'll really show the basics of how to code for computer vision. What are the libraries? What are the functions that you can use and how you can use it? Then you have to create your own problem and try to solve it using any of the algorithms. Like there are multiple algorithms that would be your uh, basically that would be your assignment, that to learn different algorithms, to learn different models apart from OpenCV. So we'll be doing OpenCV in this session. So yeah. So the short story, this short story is about my internship interview. So see, there are two things which we need to understand. Like the choice that you make is going to like stay with you forever. So like never regret what choices you make in your life. Basically, my story goes like, I had an interview just during my end semesters were going on. Like so I had one exam on Friday, my interview was on Sunday, and then Monday there was another exam. I had two choices. I had one choice to like go give the interview. The second choice was to like not even try giving the interview because of the end semester thing. I could give myself an excuse for that. So the thing is, I knew that um, it's always difficult to like postpone or prepone any of the end semesters. Even we have like other evaluations, right? So it could be a bit easier there, but for end semesters we can't do that. So I had to give my exams anyway, but I wanted to even try. So in this case, my parents and my teachers like really motivated me to make the right choice. Yeah, like I'm not saying if I would have not chosen to give the interview, it would have been a wrong choice, or if anybody does that, it's a wrong choice. It's your choice. But the thing is, you need to be firm at what you decide to do, and you need to dedicate yourself in what you decide to do. So yeah, that's a small story that I had about internship, and I hope that motivates you all to take your own decisions, consult people around you, talk to them, understand what would be right for you, and then make a decision. And after you make the decision, do not regret the decision. Like it's a part and parcel of the process. So like take it and like learn from it. So yeah, this is all what I said. These are some of the key takeaways from that one experience that I had. And I think those experiences made me who I am today. Like not just this experience, but the all other experience that I had during my college life, or even during my school, would have helped me to explore myself more than stay in fear. So yeah, like, and learning. So even if I had not, so I didn't go for the interview for with the confidence that I'm going to grab this offer or something. I went with I went with an expectation that I would learn something from this, and that is what is most important in your entire life. I wouldn't say only your student life, but in your entire life. Try to learn as much as you can, and try to be more confident about what you're learning, and like give your best. Yep. Then I had summer internship. So something about my work. I did a summer internship in the same team that I'm working as an FTE. So as I mentioned, I'm working in Surface Devices. So my summer internship was mostly on firmware part of it. Surface Devices is nothing but it's a competitive company to Apple. Like like we have Apple MacBook Airs and MacBook Pros. We have Surface Laptop, Surface Studio, Surface Hub, and a lot of other things. So I used to work. So currently I'm working on UFI, which is the next gen of BIOS, and I'm working as a like software firmware engineer. And there's a reason why I like to be in this team. It's that because I haven't learned Like I haven't experienced something like that before in college. Like I have worked in front end, I've worked in back end, I've worked in ML, I've worked in all other things. But this was something new, and that inspired me to be in the team, to like work for the team, and to like explore something new and learn more things. So whenever you do an internship anywhere, be sure that you interact, network, and connect with as many people as possible. Grab the opportunities that you get, and like make the fullest out of it. So that is what I would suggest. Then yeah, learning is the most crucial part. Like whenever you interact, try to learn something. It wouldn't be technical, it would be something else, but try to learn it. If you like somebody's quality of working, or like how the way they interact with people, try to grab it and learn it. Like that is going to help you a lot in your career. Then never give up attitude. So we always come to a point where we tend to give up on things. Like we try to solve something, it doesn't happen, we give up. Or we try to, like in general in life as well, if something goes wrong, we try to give up on it. But then that is not the right solution. Like you should never give up on anything. You should try to like solve it, understand it, and have patience. So patience is really important. Like you I remember the first day I joined my internship, like the 6 months internship that I did in Microsoft. um I was like the domain that I was working on, UFI, is a very tough domain to understand. Like if you like see it online as well, there are not many engineers who work on UFI, or there are not many UFI engineers or something like that. So it is very difficult to understand the concepts in the beginning, and people tend to give up. And I remember this thing that my manager told me: it's all about patience. Like UFI learning is not going to happen in 2 months or 2 years or like 3 months. It's going to take years and years to learn UFI. It's like if you want to be an expert, it needs time. You need to have patience, and you need to have willingness to learn it. So yeah, now that I'm in the team for more than 1.5 year, I still don't think that I know everything about UFI, because the code base is so huge. And I know that this will be the case in most of the other teams and things where where you would go and work. So yeah, like never give up. Yeah, if you don't like anything, that's another aspect of it. Like you can change your teams or something. But if you like something and you feel that it's not happening, or uh, it's not going to work out or something, like don't give up. Like keep patience, keep learning. And I'm definitely sure that each one of you is going to be a really good engineer if you follow all this in your like whenever you join your companies, and whenever you like do internships and all. So like uh yeah, then yeah, ask doubts. I would suggest you guys to ask doubts in this session as well. So please make it a point that if you have anything, ask doubts, it's fine. um and then be yeah, hello.
That's really impressive what you all just shared about your journey.
Thanks. I hope you guys follow it, and it's I
Yes,
feel
we
that
are taking.
great. Yeah, and then like be humble and yet confident. Like you need to express yourself, but not in an arrogant way. You need to put forth your points, but not in an arrogant way. You should be able to prove your point without being like without keeping your ego in front or your arrogance in front. So this could be my perspectives, but this is what I want to put forward to you. Like if you agree, follow it. If you don't, it's fine. Like your perspectives would be different, but this is what I took away from my experience. And I really try to own it, and I really try to follow these things in my life ahead. Yeah, and lastly, don't worry about your results. Focus on improving your skills and knowledge. That's the most important thing. And if you do that, be like, we have this notion that like um, there are institutes like IITs and all, where we think that people are groomed or people are taught differently. It's not like that. The concepts would be same. It's just that students, like students would put efforts, or like it's just like go and explore more things. So nothing is based on brandings and all. It's all about how are you learning. Even like people from different backgrounds in different colleges, or even I would say even people from like uh, who are not getting many privileges, okay, they would be more knowledgeable than I am, because they might be doing more exploration, they might be doing more skill improvements, knowledge, everything that they could than I am doing. So yeah, or like improve your skills and knowledge, nothing else matters. Like forget about anything else. Like if you have the right skills, the right knowledge, and the right presence of mind, I think you could easily be very successful in your life. And you wouldn't, and like keep aside the regrets that you have when you choose anything. So yeah, these are some takeaways. Okay, I feel most of the philosophical part and like takeaways and all are done. So let's start with our topic, or our agenda today, that is computer vision. So now I think you guys would wonder why I took computer vision and not something uh, like that I am currently working on. So the thing is, though I'm working in the UFI domain for the past 1.5 year or 2 years, um, uh, I mean, I was working in the field of AI and ML throughout my college. Like you all guys might know, like we have hackathons, internships, then research paper writings, etc. So I have been doing that since my entire college life, and I used to like it. So why not like take something that everyone would be interested of. And after like we got chat GPT around, AI is being talked a bit more than it used to be. So yeah, that's the reason why I took computer vision. And let's get started. So before starting, um, I had done a similar presentation before. Like I was explaining uh, people about NLP, computer vision, etc. So I've taken a few slides from that presentation to like start with, and to explain you what exactly is AI. Like I know most of you would agree that you guys know the full form of it, but then what exactly it is. So we'll be looking into these contents. Um, that is, first we'll be having an introduction. What is AI? What is it's used for? What are the applications in general, like an overview of it. Then we'll go into what computer vision is. Then we'll go into the applications of computer vision. I'll share some of my projects that I did in my like in my college journey, and that I have been exploring. And then there is what is OpenCV and how to use it. Like we'll get started with something about OpenCV. So yeah, let's move forward. Introduction to technologies behind AI. So I really like this slide. I think this would be the most favorite slide, because I really like the series that I'm showing. So this is basically like poster of Lost in Space, and we we like in that series there were there was this robot. I actually saw it a long time back, so I don't remember the name and all. And there was Bill Robinson, the kid in the picture. So the thing is, uh like, so the interaction between the machine and the robot, the boy, is very uniquely expressed in this series. And the thing is, um, when the robot gets to know about any danger that is being caused to Will, he will point out that Danger Will Robinson. He'll tell it to the boy. So there are many such series, and there are many such robots in real life. We'll be looking at some, like one of the robots, the real life robots like that we have currently. But yeah, like that is how the power of AI is. Like that is how you could like imagine AI to be. But the thing is, the truth is, it's not only robots that are using AI. Like we have different what do you say, different applications that use AI, and we don't even know it, that use machine learning, we don't even know it. So yeah, a little bit exploration into AI ML would help you understand different applications than just the materialistic things that you see. Uh so yeah um this was a brief introduction about how AI is and how AI could be. And I hope some day would come that AI, we do have AI robots like the existing ones, but more powerful, and like that would be really awesome, I think. So yeah, then let's talk about some common terms before we deep dive into computer vision. So the common terms in the field of AI are obviously artificial intelligence. So what is artificial intelligence? You can take an example. Okay, maybe let's make it interactive. Anybody would be willing to like explain what is artificial intelligence? Maybe give it a try. Like it shouldn't be right, it shouldn't be wrong, it should be fine. Like whatever you feel like. It could be as simple as giving an example of what is AI. Okay, so
Yeah.
yeah, I'll go on. So basically, artificial intelligence is nothing but a way to make machines learn, like from their past experiences. You would say ML. Then what is ML? But ML is like a subdomain of AI. So AI could be anything from like uh, your games, like computer based games, or uh, the the games that you play against computer, like chess, or maybe you can also consider AI to be Tesla cars, like the self driving cars or something like that. So that is what AI is. And and basically this technology is a roof that then undertakes all the other aspects of aspects like machine learning, deep learning, computer vision, neural language processing, etc. So you can consider AI to be a roof that has all the other common domains that we come across. Okay, then there's machine learning. Machine learning is nothing but you train models, you build models that will think analytically, like you think, and then it would help you give some outputs. So it's basically a subdomain of AI, and it trains the machine how to learn. Like it it is responsible for the learning part of the machine. Like AI could be, like I said, AI could be the roof which consists of different models and different processings or learnings. But machine learning is one thing where you have different models to like put it in a layman language. You have different models. You'll make the models running. You will train the models, and then you will like uh you you will ask the trained model to like think analytically like you do, like because it's learning from the data set that it's getting. So So yeah, like now we have done two. Like artificial intelligence is a broad domain, broad term. Then that would mimic human abilities basically. Then we have machine learning, which will make the machine learn. Then we have deep learning. So deep learning is below machine learning. Like uh, it's like a tree. Like first is AI, then it's machine learning. Under machine learning, there is deep learning. So what is deep learning? Deep learning are human-like tasks, like small tasks, right? Like re- uh, speech recognition, text recognition, or image identification. Everything comes under deep learning. So that is deep learning. Then you have NLP. NLP is natural language processing. So again, it's a branch of AI, and then you would see, like, as the term says, it's something related to how we converse with the machine, like the chatbots that we have, like Chat GPT. It's a very powerfully trained NLP application. Then your Siri, Alexa, Google, everything. Those are all like examples of NLP. Like in a broad domain, anything related to speech, like reading text, text to speech conversion, or even text comprehension, summarization, etc. Like you know, right? There are applications that would like summarize a big long text into like 4 lines. So all these are applications of natural language processing. And then there is like computer vision. Computer vision, as it says, it's like the field, like again, it's a field in artificial intelligence which deals more of with images, like image recognition, object classification, identification, face recognition. All those applications come into computer vision. It's basically like if I give you an analogy, it's like the eyes of a human, like eyes of the machine, which could identify. And also, like, it's not just capturing, it's not like a camera, it's capturing, understanding, and then giving you results based on it. So all these are some common terms that you come across, but we get confused, like what is under what. And then it's a um, huge conflict of doubt, like what exactly is happening here. So yeah, these are some common 5 terms, and I hope after this session, like if you're asked about all of these in by your uh, friends, relatives, teachers, or anybody who would be able to like give the right context and give right examples, and also would be able to like explore what is your like maybe you can take one of them. Today we are doing computer vision anyway, all of us. So after computer vision, you could take any of these, like try to see what are the models existing. Maybe if you like machine learning, try to explore that. What are the models and what can be used? Or take NLP has a huge domain, has huge scope and a lot of applications. So go into it and research something more about it. And I would say play around with AI. It's the future of tomorrow. So yeah. So as we know that our context is about computer vision, and computer vision is nothing. It's basically like our amazing human eye or the human vision that we have. But human vision is far more complex and like complex but beautiful than what we assume it to be. So how did it all start? Yeah, it all started like a billion of years ago, like when we had a small organism in the like that started mutating against the sensitivity of the light that it was getting, like that was flashing. And then fast forward to today, we have abundance, like almost everything on the planet that's living. I mean, except for trees. But yeah, I mean, like I hope you understand, like there are abundance of lives in this on this planet that have eyes now. So that's how it began. And the story of, I think, cameras to computer vision is also the same, like if you try to compare both of them. And today we can train machines We can train our computers so much powerfully that like uh, like similar to a human brain, I mean human eye or human vision, and that is called computer vision. So that's how the term is. And um and it's really so we are in an era that is doing more and more out of computer vision. We are not stopping at a point. The more the ideas, the more the creativity, and the more it could function like how a human eye functions. So yeah, this is our second topic. After the introduction, we have computer vision and what is computer vision. So this is a small representation of how a human vision works. So there are basically three parts of it: the eye, the receptors, and the visual cortex. So now basically what happens is the eye acts as an what do you say, an image receptor which captures light. Okay, then it converts into signals, and then it's transmitted to the image processing centers of the brain. Now the now this is the process in which the eye would recognize or build a picture of what it's seeing, and then it would give you an output of like out the brain would tell you what exactly you're seeing, and that's how the human vision works. So and like it's very much functional, like it's the power of human vision is much more than that of a computer vision application, right? Because the moment you see a flower in front of you, you would immediately recognize it to be a flower. You wouldn't take like even half a second to recognize that it's a flower, because your brain is already trained with the information for so long, since the day you have taken birth, that it's trying to understand, it's trying to train itself with more complex things than just a small thing. But that's how you say, when you train a machine learning model, I mean any machine learning model, be it computer vision or anything, the more the number of data you give, the better the model is going to be, the better the accuracy is going to be. And that is why the amount of, so take a live example, chat gpt. It has so much of data that it is able to answer all your questions. It is learning throughout the process, but along with that, the base foundation of it is really strong. Tomorrow, if I try to make something wherein I do not have a lot of data, my model is not will work on the trained data set, but not on the test data set. So uh, that is the difference between a human vision and a like and a computer vision. And then so we did have human vision for billions and billions of years, but now that is not just it. Like from the past several years, like almost 30 to 40 years, we have made studies and we have progressed so much that the ability of visualization has increased a lot. It started with a small camera, like a photographic camera, and coming and then it all went into like mimicking how the visual like the human eye is, to like basically training our machines to act as human eyes. So yeah, that's how it all began. Now a bit about like how the evolution of cameras happened, like because it's really important to have to understand what kind of data set you'll be having, and the quality of the data set, and how can you manage it. So it's important for us to understand how everything evolved to what it is today, because if we do not know the history of evolutions, we would not be able to like evolve ourselves or innovate something new ourselves. So yeah, like we said, the eye is for capturing the light, receptor is for processing, like receptors are in the brain to process it, and the visual cortex is for processing, sorry, the receptor is for accessing it and the cortex is for processing it. Similarly, what we have is uh, the camera that was there since the past 30 years or more, like digitalized cameras basically. uh, those we can use to collect the data, that is capture, it basically represents the eye. Then you have then you have machines to take inputs, and then you have the models that are being processed, that process the data that you give it. So yeah, so that's pretty much about the history of it. And now let's dive into what are the current scenarios of computer vision. So computer vision, as we know, it's a field in AI, and then it enables the computers to think, and uh, it's basically like, if, like I've mentioned, if AI is making you, like, is making the computer to think, then computer vision is making the computer to see, observe, and understand. And it's, I know it might sound a bit easier, like what it is, but the main thought process in using computer vision is nothing but to understand how to implement it and how to use it in the real life scenarios. uh we talked about how computer vision and human analogy is, but let us like see some of the like training, uh, not training. So basically what it does, it's nothing but it converts your image when it captures into an array. It wouldn't understand. So human functionality is a bit is a lot more different than how, uh, though human vision and computer vision look the same, they are not the same. It's very easy for humans to recognize things. As I mentioned, it takes around like less than milliseconds to like recognize simplest things that we have seen, because we have been training our minds, our the process for like our lifetime. But think about for a computer, an image is not an image. Like, how would the computer know it's a cat? So for a computer, the image is a set of array, and that array is basically so basically this image would convert into something like this, where each number will represent the value of the pixel. So now this is not exactly like it, this is not the array for this picture. I've taken it from somewhere, but it would be similar. Like something similar to this would be your output, or like the data output, and that's how the computer will understand which pixel means what in the image. And once it knows what pixel means what, it would map the pixels, and then based on the data it has, it will try to train it. So that's how computer vision works. And let's also see a fun fact in this, because I know nowadays students right from college are more interested into knowing how it's impacting the market out there. So so yeah, let's talk in terms of market growth. The basically there is a market, like a global computer vision market, which has a value of like 11.7 billion in 2021. And like last year it was expected to be 48.6 billions. So like you know how it's growing, like since 2015 to 2022, this is how it's growing in the field of computer vision and like different fields. So basically I myself have been working like in during my college period. I was working on one of the projects that was related to agriculture. Then there was one related to medical. So there are a lot of things, automators, etc. So there are a lot of things which you could try, which you could see gaps in, like in the real life, and try to fill in those. Yep. Now let's dive into more interesting things that is what is the application of computer vision. she is my favorite uh robot. She's the Sophia. I hope, how many of you knew about Sophia? Like maybe uh like can somebody tell me what Sophia is, or uh like great. So yeah. So like Sophia is a really I see hands. I like the interaction going. So yeah. So Sophia is one of my favorite robots. Okay, I had added a video, but it's not being played. Okay, so basically, this was a video. I'll let you know. So this was a video of Sophia making expressions, like human kind of expressions, like with a happy face, a sad face, a crying face, etc. So how does Sophia know that what a human is saying and how to interact? Because there are cameras installed in Sophia. So there are a lot of cameras. It's not just like the eyes of Sophia are the cameras, but there are a multiple number of cameras that are being installed. How does Sophia say hello? So Sophia tries to understand. So here she is a really great example of computer vision, NLP, and everything else in the field of AI. I would say way before ChatGPT, Sophia was the craze of many people, like who actually liked AI and all. So yeah, so in her it's implemented. She has a huge model. So when she captures, so like it's not possible in the beginning to have a model to learn everything, because not everything could be learned. Okay, so they might have a constrained data set, but Sophia wouldn't know how to do namaste, for example. She would wave, but then she learned, uh, she took some videos. So everything that Sophia interacts with is being captured as a video, then taken into frames and then used as her data set. Now this data set will help her to understand what a namaste is and who to greet with namaste. Like some person, if he does namaste to her now, she would be able to do a namaste instead of a hello. So that is how the Sophia model is getting trained. Like live camera and live video detection would help her gain more gestures and implement it in her in her everyday conversations that we have. And the more and more the more conversations she has with people, the more she'll be able, or she'll be capable of doing uh, great things. So so yeah, so basically this face recognition is also on that. So whenever it interacts with a human, it understands the human emotion, like what the human emotions are. It uses a convolutional neural network. So convolutional neural network is a model basically that is used, and then it basically uses all the information that it's getting and trains it into the neural network. So neural network is nothing but one algorithm. It's a huge like it looks like a huge neural network, but as in the nervous system that we have, because there are a lot of layers into it, like dense layers, then a lot of other layers that you can extract, hyperparameters, parameters, etc. And once you modulate or like modify all those parameters, you get a good model. And it's basically trial and error, right? Like you have to assign the values, you have to see if it's working, if you have to see if your model is trained well, the accuracy and all, and then you have to retrain the model if it's not. So that's how her models work. We might not know the exact details of it because it's a company being working on it, so we might not know exactly what what are the parameters, or what are the how the model is designed. But yeah, like uh, this is how it works. So see, if you can see, there are cameras ingested here, and there are cameras also in her eyes. So uh, so that's how she could change in a minute or so during the interaction. Like uh, not even a minute, I said a bit longer, but yeah, like the way the machine learning happens is like it extracts feature, and then it also detects the texture, the emotion, and the um, basically the edges of your facial expression, and then once you outline those, you understand if the person is supposed to, like, if Sophia is supposed to give an output of a sad thing or a happy thing. Because if she smiles on a sad statement, or or a sad conversation that is being happening, it wouldn't be a great model to use. So yeah, that is one example. Then okay, okay, yeah. So then here are some of my applications, or my projects that I did with my professors and with my college friends. So one of them was flood water depth detection. So we also used CNN, that is convolutional neural networks. So the application was mostly like, you take an image of somebody in the water, a raw image, then the image would be processed, like grayscaling, resizing, rotating. Like, okay, so basically you have to understand how you have to process your data. Fine. Now, in this case of application, we would not be able to rotate the image, because then it wouldn't be the right scenario, right? Because you have to like classify the depth of an image. What if I rotate this? How would I able to like get the depth of the water? I won't be. So you have to choose and be precise on what your data processing should look like. Then we had a convolutional neural network layer. There were several layers that we model trained, and then we got we did a trial and experiment. Like, we considered a base situation, then on top of it we started modifying the parameters and adding layers and all. And then we saw the output, the results. We were satisfied with it, and so we created uh, we started giving an output. So this is like this is not exactly how the application looked like, but this is just an interpretation of what it is. So now it wouldn't be that accurate. Like, our model would give you that this is waste deep water, but then yeah, it somewhat is. So your model wouldn't be 100% accurate anytime, and you need to like make it make it better than what it is. And yeah, I mean, it wouldn't be 100% accurate anytime. So make sure that you try to get good amount of accuracy. But yeah, like that is what you have to decide, like how much accuracy do you want, and on how much data you're going to train it. So studying about your data is most critical here. Then we had uh, COVID, right? And we wanted to like we came up with a solution for the social distancing thing, because we knew that everywhere we had like officials, like government officials who were standing, and then they were monitoring the situation. But how safe it was for those people, like, so for that we tried to have a digital solution to make sure that people everywhere are following social distancing. For this, we used a trained model, that is POSNet. So POSNet was used to like take the what do you say, like draw a skeleton on a human body, and based on the skeleton we then configured the center of the human body, and based on that we calculated the distance between them. If the distance between the two people was beyond the like beyond the announced 3 feet, yeah, 3 feet, I don't remember what the value was. Yeah, 3 feet, then it was okay. But it was within the 3 feet, like if it's 2 feet or 1 feet, then the officials would be alerted through via a message or something, and that is the only time when the officials would have to come and take actions. And it also had another condition which we tried to implement, was the number of humans. So group gathering was not allowed then. So that is one solution that we like. Basically, in this case we just have to do a head count of how many centers we had. So that's how we did it. So yeah, the only implementation. So basically, what I tried to do in my college time was I tried to implement different models rather than using one single model and taking it forward. I tried implementing like custom like CNN. So basically, CNN you can add your own layers, you can add your own parameters. But in case of PostNet, what we tried to do was our main focus was solving this problem by figuring out how many people are there, by figuring out calculating the distance between the two people. So so that is why we used a pre-trained postnet model. And yeah, so you guys can go and like read papers also. These are available papers on internet. So yeah, then there's the internship I worked in Skinsy. So in Skinsy we used a lot of models. Like, to be honest, I joined Kinsey as for ML in my third year, if I'm not wrong, and in my second year I was working on the back end of Skinsy. So the application was like you have to detect how what the disease on your skin is based on the photo that you give it. And and the model accuracy that we had was 95%, which is good actually. If you so see, like in case of skin diseases, two diseases could look very similar but are different. Like there are different types of acne. So if you put two different type, I don't remember the name of all the diseases, but yeah, like we used to see the data set. We used to like work on the data set, work on creating the data set. We never used a like available data set, or we never used pictures from internet, because pictures from internet are mostly for of white people, if you say. So and in our case we wanted it to be more India friendly. So now your data, if it's trained based on the internet images, it wouldn't give you right results. So this is also one thing that you need to be concerned of. So that is how we tried to create our model. We tried to create our own data set in this internship. And believe me or not, this internship, like I have learned a lot of things during the entire internship. Like I might have not learned it in any of the uh, maybe industrial companies, but uh, yeah, like if you are in first year or if you're in a second year, please try to get some internship that you're interested and that you think would help you learn some concepts in different things, like other things that you like. So that's it about the applications of computer vision. Now let's get started with OpenCV. And so basically, we will be using OpenCV to learn computer vision today, tomorrow, and then tomorrow onwards, you guys, or after this session, you guys could explore more about what is OpenCV. And like, or you could go ahead with some other model as well. So what I was thinking is, so I do have some slides which I've taken it from a blog, but then we could maybe like try to code something. Let me just check. Hmm. Um. Yeah. Like, are you still seeing my presentation screen?
Oh man, we actually lost it. Like we can't see the screen.
Okay. 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 I'll share another screen. I actually wanted to open a notebook, and maybe we could like Uh, so like, do you all have your laptops or something with you? Or like maybe I could show a demo and then you guys could try it on your own sometime after the session. Okay. Is a notebook visible? Like demo.ipynd?
Yeah, yeah, we can.
Okay. It's still visible, right?
Yes, yes.
Okay. So let's do a quick demo of OpenCV. Okay, so what I'll do is, um, we need an image that we can use. Let's say memes. Mm, yep. I have taken an image now in the notebook, if you see here. So the easiest way to start with Python, or if you guys have not worked any time in Python, or if your computer doesn't have Python set up, would be you could use the Colab notebook and get started with it. So yeah, like we don't have so much of time, and I we kind of lost some few minutes before we started the presentation. So like let's get started with like quick thing without any setup or something. So basically what you'll do is, so in Python you import libraries. Okay, so there's a CV2 library that you'll import, um, and like please ask me questions if you have any simple doubts. Like I am not sure if there are only first year students or other students, but if you have simplest of doubt, it's okay to ask me questions. In the call we all are learning, even I am learning with you guys. So yeah, like please tell me what questions you have, and we could like solve it together. Okay, so we are importing CV2 as CV, then we'll import numpy because we have to see what the data type of the image is, and then we will import uh, matplotlib. This is basically for like graphs and all. Lib, import matplotlib, import matplot as plt. So this as CV, as PLT, and as and NumPy is like we could use these things. Sorry, this should be from Notepad. And just run the cell. Basically, the first cell is where we are importing things. Like make in. Okay, wait. Okay, we imported libraries. Then let's get started with reading the image. So read. This would be. Let's read image. Let's read it. So how will you read it? So in OpenCV, you have one function called imread. So you will read it by that. So you write image is equal to CV because we are importing CV2 as CV. And then you write imread and you just give the image JPEG name. Okay. Then this is only reading, right? Now you have to also like display the image that you have read to understand if you are doing it correctly or not. So what you'll do is you'll do I am show, and then you would print the image. Then in I am show you also have something called like you can give title to your image. So basically what you can do is PLT I am show, oh sorry, okay, I'm sure title, and then whatever the title is, so meme, and then plt dot show. Show will basically show what you have what you're reading. So this is the image that we get. So basically the uh, um, the read thing, it's manipulating the RGB values of the image, and that is why we are getting it in this format, like with the default RGB settings. Then what you do is you could change the RGB settings, right? Like you can do it from so basically the the way you input the image would be in terms of BGR, but now if you have to convert it into RGB, you can use something like um, if let's say image RGB, okay, image RGB, and then what you'll do is CV, it has one thing called convert color to image, the image that we have import like red, and then you write what you have to convert it into. So it is CV dot color BGR to RGB. Now, after doing this, you also have to show, otherwise you wouldn't see the uh, image. I am show image RGB. See the difference? So this is how you could like get your input image. Then what you could do is to understand how this image is, or what the size of the image is, what the type of the image is, what the data type is, you would print some like you could directly use something like so basically you could, I'll show you. We could print the size which will be equal to uh, my image RGB dot shape. Oh, my bad. Sorry. Okay. Yep. So what does this stand for? This is the height, this is the width, and then this is the. So you can see here also, right? It's 1,000 and then some hundreds up. So it's 1,125. Then it's 2,000, and then 3 is the channel, like the RGB values that we have. So that is what it stands for. So it could be RGB or RBG. So anything of both the channels would tell you that it's 3, and like uh, yeah, that's what the 3 stands for. Then you could also print something like the data type. So we know that we have data types in for everything, right? So you can just typecast it as type of image RGB. So see, like we had a slide sometime back, right, where we were discussing that an image for a computer wouldn't be an image; it would be a list of a set of an array. So you can like see here that this image is basically what it's an array to for the system. Then you could also do print of um, so actually I think I made a mistake. This is not no, I think I'm right. So yeah, so this is how you could get information about the image, and this is how you could like uh, adjust or manipulate the image in OpenCV. Now this is like you can grayscale it. You can do everything that you want to with this. So I'll leave it to you to explore with the RGB values or the grayscaling of the image and all. So we could move on next to drawing something on the image, right? So what we could do is we could start with a line, because most of the data sets that you will have, you would have to like mark it like when you do data processing, you will mark a rectangle or something for the model to understand this is the part that you're focusing on or something like that. So let's go with a line, and then we implement a line on the like the reference image that we have. This is the reference image. Now suppose we have to draw a line from here to here, let's say. Like, so what you do is you give it as line image line is equal to image RGB dot copy, because you're copying the image. Sorry, I have an habit of shift enter. And then what you would do is you would draw a line on top of the image that you're taken. So we'll draw a line on top of image line and not image. Okay. because we'll be using it again and again. So so why are we making a copy? We are making a copy so that we could experiment on this image. I mean, on several duplicates of this image, rather than like just like rather than overlapping our lines or whatever figures that we'll see ahead. So yeah, so like if you do cv dot line, basically you have to give parameters. So the first parameter will be the image that you want to give. So the image that we want to give is image dash line. Guys, if you have a laptop or something with you, you could like do it along with me. You could experiment with some stuff, but if you don't have, you can just look at it. It's fine. Like it's not very difficult. I'm doing a very basic thing today. So yeah, like looking at this would give you some idea. So let's start drawing a line from 0 comma 0 from here to, let's say, some point here. Okay, like 2000. So we give the first thing is the starting coordinate. The second thing is the ending coordinate. So let's give it as 1125 comma 1125. So 1125 is somewhere here and 1125 is here. So it should be here. And then so we gave the image, we gave the starting point, we gave the ending point. Now we have to give is now we have to give three things. That is the value, like the color that you want, and also and then you have to, so color will be three parts. Okay, the value of r, the value of g, and the value of b, and then the fifth then the last parameter that you give is the thickness of the line that you have to draw. So let's draw a blue line. So blue will be, r will be 0 because we have to draw completely blue line. So then it's 255. We give the extreme value to b, and then g will be 0. And then what you do is you do 5 for the thickness. Once you have this, what you have to do, I am show and then image line. See, this is how we wanted it, like somewhere here, and then 1125 1125. So this is how you can create lines on your image. You can like experiment with some things, some different kind of things that you want. Then let's go ahead with a rectangle. I want one of you to volunteer to like tell me how I'll do it for a rectangle. It's okay. I wouldn't uh, basically I don't expect you to know the functions and all, but if you could like just tell me how to write something like something for a rectangle, it would be really great. Like um maybe the organizers could like help me picking someone, or I do not want to pick somebody. It would be better if anybody like volunteers for it. Hello guys, are you still there with
Yeah,
me, or
yeah,
or
yeah, we are.
or the
Yeah.
session is totally boring?
No, it's not boring. We'll just.
Okay, does anybody want to volunteer? There are three simple steps that we need to do. Okay, Ganesh.
Okay.
Yeah. Yeah, maybe organizers could unmute Ganesh and we can.
Yeah, yeah. I'm unmuting them.
Yeah.
Hello.
Hey, hi Ganesh.
Hi.
Thanks for volunteering.
Okay.
you're implementing one of the things I said, like you're being confident, and that's really nice. So yeah, let's get into like a rectangle, something like a rectangle.
Okay.
Yeah. So I'll give you a hint. There is a function that would help you implement a rectangle. Okay. So you don't have to use different lines to do it. You just have to implement a rectangle. So like, what are the 3 steps? So what did we do while we did a line?
Can't remember.
Okay, let's do one thing. We made a copy, right? The first thing we did was we made a copy of the existing image, right? Okay. So uh, the first thing that we did was we made a copy of the image. So what we'll do is rect img. We'll make a copy of the RGB value, right? So what was the command we did? What we did was we did image RGB
Image RG.
RGB
Okay.
dot copy, right?
Okay.
So what does this do? This makes a copy. So remember, first step, make a
Right.
copy.
Make a
Okay,
copy of an image. Okay.
right.
Sure.
Then what we do is then we use the library to create a rectangle. So there is, like we had cv dot line. Okay, we had cv dot line. Okay. So similarly, we have something called cv dot
Rectangle.
rectangle. Okay. Now what do you pass? The first parameter that you pass would be the image. Then the second parameter will be from where you have to start. Okay, the starting vertex. So it's 25 comma 50 maybe. Then the next will be, if you have the start of a rectangle, what do you need next?
Point to show.
The opposite vertex, right? If you have one vertex, if I start from here, I need the opposite vertex, right? ऐसे rectangle
Yeah.
बनाने के लिए,
Ah.
right? So what we do is we do 175 comma uh 150 maybe some random values. So we got first vertex, we got the second vertex.
And now the point.
Then uh no, not the point. We will need the color of the line, right?
Okay.
We wouldn't need 4 points. So basically, what it will do is it will start from here, because it has the starting and the ending, right? It will definitely calculate the width and the length of the rectangle, and it will draw a rectangle directly. So so it is basically same as drawing a line. Basically, what how it will implement is it has line ka vertexes, right? Then this would act as a diagonal, and along this diagonal it will create a
Square.
rectangle,
Rectangle.
right? Right. Yeah. And then again, if we could do a red thing this time. So comma 0, and then we would do the thickness as 5 again. Okay. The
नहीं.
last one is thickness.
हाँ.
Then what we do is implement flat IM show. We show the image. So basically, draw rectangle, and then IM show rect IMG. See, now there's something that we are missing. Uh, rectangle. Then we did invalid syntax. Oh, I'm missing a comma. So yeah, so this is a small box that is created. Now, if we change this values, right, we do it something like 1 170 तो नहीं है, 1800 and then something like 1500. You would create a big box, right? It's going out of this because I gave 1500, which is not even the length of the image. So that's how you know how to give it. So I just inverse it 1500 and then we give 800.
Cool.
It will create a box. So
Thickness,
that, yeah.
thickness we let's change the thickness now.
I didn't understand, Ganesh.
Change the thickness also. It's not kind of.
Yeah, we could change that. So it's visible now. Okay, so this is how you could so like after your model is trained, right? You want the model to show like where the face is. So that's how your model could draw faces, or like this basically right now is what we are hard coding, but this is how your model will get the values, and it will like display that this is the face in your image, right? So that's how you do it. So because we did rectangle, uh yeah, let me just get it in right this thing. Okay, yeah. Now we learned about line, we learned about rectangle. We can also do a fully colored circle. Okay, so circle, for circle, yeah, now we saw what are the steps, right? We did it twice. Now I want somebody else. Thanks Ganesh for volunteering last time, but I really want somebody else maybe to go ahead and like help me with this. If somebody is not volunteering, I'll pick up. Yeah, okay. Vishal. Uh, I think Vishal was raising the hand, so maybe we could unmute him.
Yeah, trying to unmute them.
Okay.
Hello.
Hi Vishal. Yeah. So yeah, tell me the 3 steps first. Like what are the 3 steps?
First, we have to read the image.
The image we have read, right? We have to use the read image to copy, right? Copy.
Okay, copy.
We do have an image, right? We read the image here. We have it stored in this variable img rgb, right? So what we'll do is we need to create a copy out of this image that we have stored. Okay, so that we don't really impact the image that we have read. So what we'll do first, copy. Okay, then the next thing,
Next, we have to provide the properties.
right? So add circle and input parameters. Okay, you are right. And then third,
Third,
Now we have the things ready, right? What are we supposed to do? Like take an
display.
analogy, right? I was just going to give you an analogy of Master Chef. They have things ready. What do they do after that? So yeah, so let's go ahead with this. Or what will we do if we have to copy? We'll take a variable, right? Maybe circle image. Okay. Then what we'll do is image RGB. RGB is the image that we read. Okay, Vishal. So we don't have to read it back. We'll use this image itself and then we'll create a copy of this image. Okay. Then what we'll do is we'll do cv dot circle karke library we'll use, and in this we'll give parameters. Now for circle it's a bit different than the parameters that we gave it to line and a rectangle, right? So what are the parameters that we have to give here? First we do have to give the image. So what we'll do is we'll give circle img. Okay. Then what we'll do, then we'll give what are the properties of a circle, like what do we need if we want a circle.
Color and thickness.
No, so I'm asking you the property of a circle, like not the mm, what do you say, not the display categories, but like how do you draw a circle on a paper, like what do you need for drawing a circle?
Radius.
Right, radius, and only radius, you know where to draw, like what coordinate do you need? You know the
Radius.
radius, right? Where will you keep your rounder ka pointer? Where are you supposed to keep it? For that, you'll need a coordinate, right? Center, right?
Yes.
So we need a center. So let's say we take the center as 750 and 600 maybe. Okay. 750, 600. Then what we do is we give radius. What radius do you want it to be? Maybe let's take a 90. Okay. And then uh, this radius is in pixels, okay, because the image is considered to be in pixels, so the radius is also in pixels. And then what do you need? The thing which you said before,
Color and thickness.
color. So now if you have to give RGB blue color, what will the coordinates be?
255, 0.
No, we need blue, so RGB. So which position is B?
00255.
Right, 0 0 0 2 double 5. And then there is one more parameter that is like, so this will be the thickness, right, like you mentioned. But what if you give a negative thickness, what will happen? So when you give a negative thickness, the entire circle will be an opaque circle, like it will be filled up. Okay, so that is what the thickness stands for. Now what we have to do, we have to do I am show circle image. See, there's this thing, because our radius is very small. It's not great. Let's just give it a huge one. Now this is very huge. Okay, so this is how you are going to experiment it. Like just keep giving some radius, or like check what is the exact value, right? Like this is a fun tutorial because you can try a lot of things. You can um, take your friend's picture and you can animate it or something, like animate as in you can put circles and all with this thing. And then once you know how to use it, you could like use OpenCV in a lot of places. So yeah. So okay. So now we have added this picture, like this shapes and all to the image. There are also different things in OpenCV, like you can blur, you can Gaussian blur the image and stuff like that, so that you can use or grayscale the image, so that you can use it for like the processed images can be used as data sets, and yeah, like it really helps in doing a lot of things. So now let's add one more thing. Now, if you have a model and then you like have to like when you display the image to a user, you have to also like based on the model you have to say. So you have seen images like this, right, on internet or somewhere, like where it's detecting the face, and if there is no mask, it's written here as no mask, right? So let's try to add a text to the image. So what you'll do is, so this is a bit different, that is why I'm not picking up anybody to like tell me how to do it. So let's, first step is same, create a copy, rgb.copy, then it's what font do you want. Font is equal to, CV has some fonts, so you can use those fonts, like one of them is font uh Hershey, like this one maybe. Then you have text ka color, so you take a variable to define a color. So I want it to be white maybe, because the image is dark. So 25, 25, and then I do CV dash put text. So put text is the function for this. Then it's similar, like what you do is, first is text image, then you pass what text do you want. So I say funny meme or something like that. Then what you do is, you give the uh, like how do you want it to be written as, where do you want it to be written as, the coordinates basically, from where to start. So let's say we are starting from uh 120 1250 and 1000. Okay, and then you would give the font, and you will give the text color. Then see, it's prompting you what all we have to give, right? Like put text is, first is image, then text, then like then the origin is basically where you want to start with, the font face, the font scale, like what scale do you want it in. So let's put 2. Okay, then we give text color. So this is basically, you could directly put it here like this, like we were doing last time, but keeping variables would, it makes it easier, like makes it more readable, and it helps it's a good industry standard basically. Okay, then if you want, you could again like see what all parameters do we have to give. Then we have to also give cv dot line a, oh my bad, sorry. So there are a couple of more what do you say, um, parameters in this, and so basically the third, like the second after like what do you say, this is image, this is image, this is text, this is origin, this is the font, what font do you want. Then this is what did we say, I'm really sorry, I'm blanking out. Yeah, the font scale. Then this is the color of the text that you want to add in. Then this is the thickness of the font or the text basically that you're going to add it, and it's also in pixel. And then this is like if it checks it if it's a line type or not. Okay, so this is what it is. And then you go cv.im show. Yep, we are doing this on text image. So text image. Okay, I know you guys have another workshop in like at 4, so let me just do it fast. Okay, I think this is I made a mistake here. 9. Show is disabled in Colab because it causes Jupyter session. Okay, okay, sorry. My bad. So see, we have it here, right? We could increase the thickness to 12, and then yep, we have texts here. So similarly, you can do a lot of more things with this, and like add text to your images and stuff. So yeah, that was it. And then one last thing, how would you save your image? Like you could save it in a variable, but then like you want to just like save it in your code base, right? Then what would you do in that case? You would just use another function which is cv dot. So what we are doing, we are writing, and then what do we have to do? We have to sorry, we are reading, and then what do we have to do? We have to write the image. Save is nothing but write it, right? In terms of your computer. So in terms of machine. So what you'll do, I am write, and then you will give the name of the file that you want to save it as. So I'll save it as funny underscore meme, and then jpg. And then which image do you have to save? Like I have to save this image which has funny underscore this written, but I will do one thing. I will change it to 3. Yeah, and then I will save this. Okay, so that is how it's getting saved. So uh, you should see it actually here. I'm sorry. See it here. Okay, so basically it gets saved here, like where your image is, right? Where the image that you imported is, it will get saved there. I lost the file that I was using, the folder basically. No worries, but like when you try it yourself, you'll understand that it gets saved here somewhere. So yeah, that's all about it. And if anybody has any doubts, like we can take questions now. Like any doubts are okay, like about anything if you want to ask. So yeah, please go ahead. I've stopped the screen sharing, so just like yeah, Vishan.
Can you share the screen again?
Okay. One second, I think. Huh. The notebook page, right? Is it visible?
Yes, that circle wala line.
Okay.
उधर लास्ट में CV डॉट सर्कल में लास्ट में -1 लिखा है ना,
Hmm.
उसको 1 और 0 में चेंज करके देखो ना, मेरे को आउटपुट देखना है.
1 will be the thickness, right? एकदम पतला circle. 0 will be nothing. I think what they're doing is 0 also they're keeping some thickness, so because you're giving the parameter, but it's almost like nothing. Okay.
डिफॉल्ट वैल्यू क्या है उसका?
Default value as in you
मतलब
have
अगर
to
नहीं
give
डाला तो
नहीं डाला तो it like it should be 0, right?
ओके.
See,
और
like when you
वो
don't
जो
give a parameter, default will be null. Like in most of the cases, it's null or 0. Okay? Now, if you give the parameters, it will keep changing.
ओके, वो जो डिस्प्ले में प्लॉट लिब है
Hmm.
डॉट इमेज हो,
I'm sure. हाँ.
उसके जगह हम लोग अगर CV2 डाल के लिखेंगे तो
I did that, right? I did the mistake here, but I was getting an error because Google Colab doesn't like let you. Yeah, it doesn't support that. It's disabled specifically for Google Colab, so that's why.
ओके ओके.
Yep. Yeah. Any other questions?
Yeah, guys, you can ask your questions if you want, if you have any doubts.
The best thing would be like what Vishal just did, right? He asked me questions, but what you could also do is you could experiment on your own. Like it's really fun. Like once you start doing it, and like how many of you are from first years? Like most of you?
Yeah, usually most of us are from second years, but we do have first years.
Okay, okay. Yeah, I mean, like for first years and second years, it's something interesting to do. Like if you have never done it, so you guys should explore more on it. Uh, like just experiment with the parameters, right? Like Vishal did that. He asked me a couple of questions where I we could experiment with the parameters, see the output live. So yeah, something like that would really be beneficial for you all.
Absolutely, absolutely.
Yeah, maybe if there are, I don't see any hands raised. If you have, we could wait for like a couple of minutes more, and if not, we could like end the session.
I'm sure people have something to ask about, but it was a very knowledgeable session.
Yeah, I hope that was yeah, like my intention was mostly to like I spoke to the committee as well, right? Like before having the session, and they were like something like a demo would really help. But yeah, I thought I would do a basic demo and like the so like what you guys could do is right like to leverage this more. You guys could like I said before, right? You guys could like go and explore more. That is one thing. But you guys could, after exploring, like take a real life problem statement and try to solve it. That would be like really helpful, and it could turn out to be one of your projects in your profile. So it's like plus plus. So yeah, you guys can do that.
Actually, I do have some questions about your journey at Microsoft.
Okay. Yeah.
Like,
Yeah.
how did it all start, and how did you feel in the beginning, like working at a multinational company and such a big player in the market?
So basically, I did not really start with, like, I started with zero expectations, to be honest, right? Like, because my only goal was to, like, learn as much as I could in all of the phases. Like, so be it an internship at a startup or an internship anywhere else or being an FTE. Yeah, initially it's a bit, like, what do you say? It's a bit difficult to, like, get started with, like, to understand stuff, to understand the concepts. And for me it was completely different, as I mentioned earlier as well, right? Because I was going into something that we don't usually do in our college. Like, we don't have a laptop that we are going to manufacture or something. Okay. So that's how it began. And luckily, I was in a really great project, which got launched, I think, in I think the project got launched by Satya himself, in the Microsoft Build event. So it was huge. Like, the 1 year that I had, it was incredible to, like, learn, to explore, to meet new people, and like, yeah, and take up responsibilities. So the only thing I did was I never said no to anything. Like, I whatever opportunities I got, I didn't really say no to anything, or like, I gave my best as much as I could. And that's what I think everybody does, and everybody should do, like, continue doing. Yeah, I prioritized my work more than a lot of other things. Like, I do, like, I'm not, I don't have a lot of, like, social life outside work. I try to indulge in work, and, like, uh, spend my weekends on work. So that is why I was saying yesterday night also I was busy working on some critical issues, and I wanted to polish up my presentations a bit, but I couldn't get time. So yeah, that's one thing that that's there.
It was amazing. The one which you gave right now, the presentation was really good.
Thanks. Yeah. Okay, I'm sorry, how do you pronounce your name? Like,
Bashar, Bashar.
Bashar. Okay. Yeah.
Yeah.
I think Ganesh has a question.
Yeah, people have questions.
Okay.
Am I audible?
Yeah.
Could you elaborate more about your journey? Like, how did you got into software, and what are your skills that led you to Microsoft or any other companies? And how
Um.
did such
Mhm.
internship that led you to such big project?
Okay. Okay. Sure. So basically, I was an off-campus student. Like, Microsoft doesn't come to our campus. Like, I don't think in Mumbai it comes to most of the campuses. So yeah, we were the same. Like, it didn't come to our campus. I applied it off campus, and then uh, like, basically the preparation, like, I didn't prepare a lot. I mean, like, I didn't focus like I have to crack this particular interview or something. It's basically a long ongoing process that I used to follow, like, some, like, practice something, or, like, basically my concepts were clear. Like, even if I don't even if I didn't practice a lot, like, at once, having concepts clear, having like, a good understanding for problem solving, that were two important things, I think. Because see, like, you can do hundreds of problems, like, it's different for everybody, but for me, what I feel is, even if you do two problems, right? The two problems, if you do it thoroughly and properly, you would actually gain a lot more than doing 100 problems. That's there. So yeah, once you get a hang of doing some problems or something, then you can increase your capacity or the thing of doing problems. But in the beginning, start slow, like really slow. Do one problem at a time, understand the problem. So I do have a like sibling, and she's also in first year. Okay, so it's like when I try to guide her, I would say the same things to her, like start slow, like one problem at a time, understand the problem, and then go through the solution as well, like see what are different perspectives of one problem. Because sometimes your problem you would think it's right, but then there are some edge cases that come into picture which wouldn't be satisfied with your solution. So yeah, and again, when you give interviews, you should be loud enough, like you should talk loud enough, as in, or not by voice. Basically, you should talk through your solution to the interviewer, and you should consider all the edge cases. So all this comes when you start thinking analytically. Okay, so yeah, I mean, like start with one problem a day or something, and then go ahead with solving multiple problems, or hacker rank, or the code chef thing. I wasn't a competitive coder, so yeah, my main focus was uh, like projects, initiatives, and like not initiatives as in not committee wise, but mostly like research projects, and then like core understanding of computer science concepts.
What was your background in college? Was you a computer student or any other?
Yeah, I was a computer science student.
मैं एक क्वेश्चन पूछूं?
हाँ, yeah, go ahead.
थोड़ा टफ है। ये जो माइक्रोसॉफ्ट में अभी तक जो सबसे मुश्किल टास्क या फिर जो रिग्रेट लगा कि कुछ तो और थोड़ा मेहनत करती तो शायद गूगल में, या फिर कुछ तो गलती से बताओ।
हाँ, I understand your question. So, uh, it's for interviews and all, right?
यस।
Hello. Okay. Uh, so the thing is, I didn't apply after I got into Microsoft, and Microsoft was the first company that offered me. So I didn't apply after that to any other companies because I really liked what I did during my internship. So so yeah, that's one thing.
Hello.
Yeah. Hello.
As I'm from ETR and I'm an ETRX student, so could you tell me more how to get into such coding and what should be the first priority and what types of language are used mostly in such type of company?
See, the language that are being used in companies or industries are pretty much very different than what you'll be having or what you will use during your interviews. So, like, focus on the interviews first, like whenever you start with. So, like, there's no constraint about what language you should use during your interviews. Like, C, it could be C or it could be Python. Okay. So I used to use both these languages during my brainstormings and during my interview. So see, honestly, I gave like one interview in college before getting before before getting placed in Microsoft, and I participated in one hackathon through which I got an offer, and then I got this Microsoft offer. So I have not, I have not given a lot of interviews, but the interviews that I gave were the interviews wherein I actually used both mix of both C and Python. Like it's fine. Like the interviewer wouldn't ask you to like focus on any one language. But ये दो languages you guys can like start with. Then you could start with frameworks for your projects and all, try to maintain your profile. I think projects really impact a lot. Like you guys should really have good projects. Like, there are two things. If you are not a competitive coder, you should have a good profile with your projects. Like, with by saying competitive coding, I mean like the 5-star thing on CodeChef and all, right? That's what I mean. No, competitive coding is not what you practice on HackerRank and all. Okay, so that is different. That you guys have to do. Data structures you have to do. Algorithms you have to do. But when I said I am not a competitive coder, that's what I meant. Like, I'm not a 5-star code chef or something like that. That's not my way of learning coding or way of understanding concepts.
What is the turning path of your life?
Uh, I have not thought of it. Like, yeah, uh, I don't know if I'm able to answer this question. I'm really sorry. I have never thought of it. See, I'll tell you, in college life, I'll tell you my third year, yeah, like end of second year onwards, the way we started participating in hackathons and we started winning the competitions was pretty much the time when all our friends, or like my friends, me, all of us started gaining confidence, and like we started understanding what actually it means to be an engineer, or what actually it means to be a problem solver. So yeah, maybe if that answers your question, I'm not sure. Okay, cool. I think that's it.
Any more
That's it then.
questions?
Yeah, I
Does
think we
anyone
do
have
have.
any more questions? I think so.
Yeah, I think we do have like 2.5 minutes more, so you could take up questions if you want. Yeah, and like one suggestion on like what Vishal asked me some time back. I had to add this, but I couldn't. So he asked me if I had some like what went wrong in my other interviews or something like that, right? So my first interview was with one company. Like, was it Credit Suisse? I think, I'm not sure, but in that interview, what I felt was I was not confident enough to answer the questions, like, because it was my first interview. So yeah, there are times like that when you have to, when you are not that confident, but what makes you confident is the practice and the hard work you do after that. So um, and the willingness to do it. So basically, I had a firm this thing in my mind that I don't want to be in fintechs. I wanted to be in product companies, um, and and then like that was one reason why I didn't even prepare that well for the fintech company that I gave the interview in. But it depends on person to person, where do you want to go, and what do you want to get into. And like, as I came into Microsoft, I really liked the culture here. I really liked the work I was doing, something different, and that is why I never tried to um, switch the company, or like, because like I would say choose something that you like, and based on how the culture is, because the thing is, the brand name uh, or anything else, if you have two companies, like we are comparing Microsoft and Google, maybe there are some differences, but I feel that the differences are not much as compared to what I'm experiencing right now. Like I would give more preference to the culture that I am in here right now. I don't know the culture there, it would be great, but yeah, but unless and until I don't feel like switching, I pull myself back by for doing that. Like uh, yeah, like 6 months or 1 year is not enough to learn something. So yeah, that's one reason uh, why you should like focus more on learning and focus more on where you like, if you like the place you are in. Like even in case of projects, right, you should not do projects just for like adding it to your profile. You should do projects if you really think you're solving a problem. So a minute problem would also be solved by some basic solution, okay, that nobody has come up with. So yeah, like the digital solution one that we had, like the social distancing one, that was a very minimal thing which was done manually, but we thought, why to do it manually, right? So that is how you should think about different scenarios, different problems, and try to solve it. Yep. Yeah, I think
Yeah.
that's it. I think, yeah.
Okay, guys. So here we come to an end of this amazing workshop. I hope you all had a really great time and made some unforgettable learnings. On behalf of CSI, I would like to thank you all for being a part of this event. And before we sign off, I would like to thank Ms. Sarah for conducting such a good event. And once again, thank you for our convener, Sir Amit Nerurkar, Sir Amit Elani, and the executives of CSI, Yash Khote, Ms. Sakshi Endulkar, and Ms. Trisha Shah, and the whole CSI heads and team. Thank you so much, participants, for being here, and hope you have taken some great output out of this. And you've been a wonderful audience today. This is me, Bashar, signing off. Thank you.
Thank you all. Bye.